Let us move on to the another topic, that is preferential attachment model. Preferential attachment model. So I already told you that attachment model is nothing but giving preferences to a node which has high probability or degree. So preferential, we will be calling it as PAM. Preferential attachment model. So we will be calling it as PAM, preferential attachment model. What we will be doing is that we will be giving the node which has high preferential. So we will be connecting the nodes which have high preferential in the network. That is what preferential attachment model deals with. We will be having an algorithm. I will explain each and every step of the algorithm, and I will be explaining with one example. So this preferential model is also called as rich get richer. So there are many ways. So let me write. So actual definition of preferential attachment model is giving most preference to the node preference to the node which have high probability or degree. That is what preferential attachment model is. For example, consider this graph. So consider this A, B, C, D, E, F, G. There is a one connection, that is E, F, G, H. So now for which node we have to attach this H? That is what the preferential attachment deals with. So consider this C. The degree of C is 1. The degree of what is this? D is 1. The degree of A is 2. The degree of B is 3. The degree of E is 1. The degree of F is 1. The degree of G is 1. So now we have to select which degree is higher. That is which degree or the probability, high probability. We will be dealing with high probability, or in case if you don't know how to calculate the probability, then go with the degree. That's it. So degree. So which is the highest degree here? Yes, that is the B1. So H will be connected to B. That is what preferential attachment model deals with, because they feel that this type of community has the high interest and high information sharing than a community. That is what preferential attachment deals with. There is a small algorithm. I will explain the step in the algorithm. So algorithm, preferential attachment model. So let's start with two nodes connected by an edge. I will write the algorithm first, then I will explain each step. At each time step, add a new node with an edge connecting it to an existing node. Third step is choose the node connect to at random with probability proportional to each node degrees. So this is the last step. The probability of connecting a node U of degree connecting to a node as consider the node as W of degree is given by the formula KW is equal to KW by sigma J KW. KW is nothing but the probability. Okay. So this is the algorithm. So let us I will explain each step in the algorithm. Start with the two nodes connected by an edge. So start with the two nodes connected by an edge. So there is one edge and two nodes. At each time step, add a new node with an edge connecting to an existing node. So we have to add every edge to the existing node, so that it makes a cluster, or it makes the attachment. So we have discussed here, right? This is what it is speaking all about. So we have an edge, so we will be connecting to the one of the existing edge. So choose a node, connect to the at random. Choose a node, connect to at random with probability proportional to each node's degree. So we, in case this algorithm for the probability. In case if you need the algorithm for degree, just replace probability with degree. Then it will be degree preferential attachment model, or it will be probability preferential attachment model. Anyway, you can define it as. So probability PPAM, for degree DPAM. That is what it is. So this is what the algorithm deals about, proportional to each node's degree. The probability of connecting to a node's W of degrees given by the formula. This is a formula they have given. So I will explain why it is with an example. So we will be using this algorithm itself. So let us take 2 points, point A and point B. Point A and point B. What is the probability? I will discuss here it in the probability level. Later I will explain it in the degree level. So let us take the probability PPAM, that is probability preferential attachment model. For example, we have taken same algorithm for both the degree and as well as the probability. So we have so start with two nodes connected by an edge. So we have taken two nodes connected by an edge. So at each time step, add a new node with an edge connected to it and to an existing node. So before connecting, let us write the probability. So what is the probability of A? A is connected to B. So 1 by 2, and B is connected to A. So 1 by 2. So I think hope you get the why did I write 1 by 2. So at each time step, add a new node with an edge connected to it. So let's add an edge to A. So edge we have added to A. So let's make it C. So what will the probability of C will be? For C we have to calculate from B. That is what it is. So from B, 1, 2, 3, 4, 4. It will be, for the probability it will be 4. From C2 we have to calculate D. C 1, 2, 3, 4. So the probability of B will be 1 by 4 now. So what is the probability of A? Probability of A is nothing but the probability of C and B. That is 1 by 4 plus 1 by 4 is equal to 1 by 2. That is 2 by 4 is equal to 2 by, we will be resulting 2 by 4. That is nothing but 1 by 2. So we got 1 by 2, right? That is what we will be doing. So connect now one more edge to B. So now to calculate this probability, we have to come from this side. So 1, 2, 3, 4, 5, 6. So probability of this node will be 1, 2, 6. So name it as D. So to calculate this node probability, we have to start from this. So 1, 2, 3, 4, 5, 6. So we will be having 1 by 6 probability as of C. So to calculate A node, we will be starting from here. 1, 2, 3, 4. That is, here it will be 1, 2, 3. So here it will be 1 by 3. How it is? Let us add these two values. 1 by 6 plus 1 by 6 is equal to 2 by 6 is equal to 1 by 3. So this is what we will be getting probability. For B also it will be 1 by 3 itself. 1, 2, 3. That is 1 by 3. So from C, 1, 2, 3. So 1 by 3. So 1 by 3. From D, 1, 2, 3. So 1 by 3. This is how we will be getting and dealing with the PPAM, that is probability preferential attachment model. So let us make another edge. So let us name as E. So to find the E, this vertex, we have to start from this vertex. So 1, 2, 3, 4, 5, 6, 7, 8. So it is 1 by 8. For C, we have to calculate 1, 2, 3, 4, 5, 6, 7, 8. So it is 1 by 8. So now we have to calculate for B. 1, 2, 3, 4. That is, it is 1 by 4. 1, 2, 3. So 1 by 3 for B. First we have to calculate for A, right? 1, 2. So it is 1 by 2. So for D, 1, 2, 3, 4. It will be 1 by 4. So this is the way we need to calculate the PPAM. So let us now find the DPAM. That is degree preferential attachment model, DPAM. So DPAM is nothing but we'll be adding the links based upon our degree. So we have taken the two vertices with an edge. Now connect. We have same vertex, same degree for A and same degree for B. So which node we have to give, that depends on ourselves, that we have to predict it randomly. So I will be adding for A, that is I will make this as C, and this degree is 1 and the degree become 2. So for the remaining, what we have to do, we should add another node, right? For the another node, we have to check which node has the highest preference, 1, 2 or 1. Which node is having highest preferences 2. So if you don't want to like to give the preference to A, you can give any of the preferences. So for example, if I want to give to the preference to the B, so the degree of 1 will be, degree of D will be 1 and degree of B will be degree of 2. So now if you want to add a new node, then we have to check the highest degree. What is it? 2 and for A it is 2, for B it is 2. We can give any of the, we can give the preference randomly. So I will be giving for B. So it is E. So E degree is 1. So B degree will be 3. So this is how we will be giving. For the next node, for 3 it is there. So 3 will be getting. 3 will be getting 4 nodes. For next node, for A I will be giving. So A will be having degree 3 and F will be having degree 2. So this is how the DPAM works. Degree Preferential Attachment Model. That's all about degree. That's all about PPAM. This PAM, that is Preferential Attachment Model, is also called as rich get richer. Why it is rich get richer? Because the model which has the highest degree will be accumulating with the new nodes. That's why it is called rich get richer. So that's all about Preferential Attachment Model. I think we have covered the Preferential Attachment Model. So there is last one topic that we need to cover, that is community. So we'll be discussing community from now. So now we'll be discussing about community. Community is nothing but a group of people. In generally, what is community? Community in our social networking, that community are the parts of the graphs that have denser connections inside and fewer connections with the rest of the graph. That is what we will be seeing in locally. For example, if we live in a village called A and we will be having a same type of communication and connections with the neighbors of our house, but we doesn't have the connections from beside our village. So that is what it is. Community are the parts. So community are those parts of the graph that have denser connection while denser connections inside and fewer connections with the rest of the graph. So the basic example for this community is nothing but the Facebook. So in Facebook, we will be having in our friend list, we'll be having a friend list of our high school, that is your elementary school or high school, and we'll be having our college level and family and friends. The one of example is nothing but the Facebook. Facebook is the best example for any social networking. Social networking. In Facebook, we'll be having a cluster of our high school members, and we will be having a cluster or community of our college members, college friends, and another cluster will be having our family. We'll be sharing our ID with our family, and also we'll be sharing with our relatives or with the friends we have. So this is what Facebook already deals with. So to make a community, we'll be doing like this. In case if high school, in one of your friend of high school is your college mate, right? So if, one of your family member is your college mate, so one of your friend is from your high school, so there will be a much what we'll call interlinking between these communities. So for example, if there is a few members who shares the features, for example, this is called high school and this is college, CLG, right? It's college, and this is family and this is friends. So there will be a mutual connections between all this community. That is what we'll be calling as community. So this all type of group of people came together to form a community, right? I think hope you got my point. So we got the people from high school, we got people from college, we got people from the family as well as friends. These all combined together to form a community, to form a strong community where they can share information with everyone they like. For example, if your high school friend doesn't know the member of your college, but he can send you a send him or her a friend request, right? That is what it is. Facebook mainly deals with the community purposes. So we'll be seeing the different types of different types of communities. So there are two types of communities. We can say that three types of communities. One is non overlapping community, and the non overlapping community and overlapping community. So what is non-overlapping community? In non-overlapping community, we will be not having any mutual friend in any mutual node in between the communities. For example, this is one of the community, and this is one community, and this is one community. We will be don't having any node which is connected to each and every community, but there will be a one link that it can share by sending a request. So if any request is sent from different clusters, for example, this is cluster A, cluster B, as well as cluster C, so we are not overlapping with any of the clusters, but in case there may be a chance that A can send a connection request to B, and B can send a connection request to one of its numbers B dash, and B dash can send a communication request to C. So that is what it is overlapping. But because these two communications are not overlapping and there are no mutual friends between among this is called as non-overlapping clustering. Whereas coming to the overlapping clustering, we'll be having the same mutual nodes between all those clusters. So these are called mutual. This area is called mutual connections between all those. This area is called mutual connection between A and B and C. So these type of communities are overlap. For example, you can see that we'll be having our friends, family, brother and sister, all those comes under this type of overlapping communities. So there is another type. I think hope you understand what is overlapping community. We'll be having the some mutualness in the community. Like for example, in consider Facebook, if one of your friend is consider Facebook, one of your friend is nothing but is one of the family member, right? So this is how it will be mutual exclusive. So there is one more type of community that is called, that is not tile community. Tile title is not title, tile overlapping community. What is tile overlapping community is that it will be sharing a some tile part, that is some immense part. For example, this is tile 1, so this is tile 2. So tile 1 is placed upon the tile 2, that it is having same mutual connections of some part of the T1. That is what it is, tile overlapping connections. For example, consider this graph. Consider this as a one graph, and this has one graph. So this is one type, this is one community, and so this is one community. What happened, these two communities are different, but they have tiled up to form a tiled overlapping community, because some of the part of the two communities, community A and community B, have the same similarities between the other community and this community also. These are the types of communities. So that's all about community. So let us discuss another topic called community detection. So how we need to detect a community. So now let us discuss community detections. There are many types of community detection, but basically mostly we'll be seeing only 5 types of community detections. Well, first one is eyewitness edge removal. Eyewitness edge removal. And second one is hierarchical clustering. Third one is label propagation. Fourth one is finding glitch. And fifth one is K-clutch percolate. So KCP, K-clutch percolate. We'll be dealing with this 5. I will explain. I will write the full form. Don't worry. So these are the 5 main community detection techniques. So let me go into the brief. So community detection is nothing but we'll be separating each and every community based upon, for example, if there are crows and there are eggs. combined, but we have to make that N should be placed in separate group and X should be placed in separate group. That is what all about community detection. We'll detect and we'll be separate and we'll be segregating all those community into different types. So let us discuss the first one, that is HBER, that is I betweenness, I betweenness edge removal. So we have already seen that what is betweenness centrality. So in betweenness centrality, what we'll be seeing that we'll be from two clusters, we'll be make for two clusters or two graphs, we'll make one node as a bridge node, and we'll be seeing that path is passing through that bridge or not. That is what here. If that bridge is not there, what will happen? For example, if this is one of the community and this is one community, and there is a bridge node called bridge node A. If there is no bridge node A, what will happen? These two community will be separate segregated. So this is one of the technique, right? So simplest technique and edge removal between. So I betweenness edge removal. For example, if there is another edges, so we have to check which edge has the I betweenness centrality, and we have to remove those edge. By removing those edge will be resulting in segregation of the two clusters. That is what I betweenness edge removal is. So let me point all those members in the density are densely connected and have many paths, but nodes from different communities required intercommunication like to reach each other. So they should be have some equal path. They should somehow have a path to reach from cluster A to cluster B. So there should be a path. Without that they can't reach or share information. So that might be one of the point. So members in the clusters or density are densely connected. So density or anything densely or cluster, anything you can call, are densely connected and have many paths but nodes from different communities requires inter community links to reach each other. So that is what here A dash deals with. So this is one inter community link for A as well as B. So that is what the first step refers to, because B without A can't send the information to the cluster, for example A that's cluster C. So that is the way. So by removing this edge I betweenness edge removal, we can segregate that community into two types, right? So that might be one of the point. So by removing I betweenness centrality, what will happen? The graph will be segregated. Be segregated or separated based on your language use. Segregated into different communities. So there is one algorithm to how to find the I betweenness centrality. There are 2-3 steps the steps we already know. So algorithm. What is an algorithm? Step 1. For each edge, compute betweenness score. That is betweenness centrality we have to find for each and every node. Find betweenness, WEN, right? Betweenness centrality or score, anything is same. Betweenness centrality or score for each node. Second step what we should do, we should remove those edge. That's it. Remove the edge with I betweenness centrality. And third step is to see, we have to remove all the betweenness centrality and until we have to segregate enough. So until there are enough segregation. So we, unless we make a proper segregation or proper clustering, we should not move from the second step. Enough segregation. So this is a small algorithm. The basic steps we already know, but we have to define some algorithm to do know, right? So that's it. This is the algorithm I between a CJ removal. So let's just move to the another community detection, that is hierarchical clustering. What is hierarchical clustering? So we'll be having so many clusters, right? So which cluster has to be the most important cluster, and which cluster will be the least cluster? We'll be removing all those clusters, or we should make those segregations, then later we can remove if that has the same similar pieces, or we can merge them. That is what hierarchical clustering deals with. So for example, I will explain it within a graph, right? Here clustering. What is hierarchical clustering? Let me take a graph here. So this is one of the graph, and there are nodes A, B, and we have here C as well as G, and we have one more node E. Okay, so based on this graph we can group them as communities, right? So AB can belong to one community, and CD can belong to one community, and E is closest to CD or AB. So E is closest to CD, so we can make another community with this. So this is what these two communities can come under different community, right? So this is one of the biggest community, and that community we have ECD, and in ECD we have CD, and in CD we have CD, and in AB we have A as a different cluster and B as a different cluster. We have grouped together. So what is hierarchical clustering? We'll be hierarchically basing those clusters. So hierarchical cluster is also of two types: agglomerate and divisive. So let me write. Hierarchical clustering is divided into agglomerative hierarchical clustering and divisive hierarchical clustering. What is agglomerative? So agglomerative is nothing but we'll be starting from bottom to up. That is, we'll be giving the least preference to the most preference to the bottom level. Then we'll be moving on to build our clusters. So that what will happen from list, if we start from the list, we'll be easily can easily segregate the clusters. For example, coming to the graph, so what are the nodes in this graph?